The earliest computers were not machines, but tools. People used them for counting and calculating. One of the earliest examples is the abacus. The abacus originated in ancient Mesopotamia. It uses beads on rods to represent numbers. Merchants and mathematicians used the abacus for centuries. It helped them with addition, subtraction, multiplication, and even division. Another important invention was the slide rule. William Oughtred invented the slide rule in the 17th century. It used logarithmic scales to perform complex calculations. Slide rules became essential tools for engineers, scientists, and navigators. They were used for centuries. The desire for more complex calculations drove further innovation. People wanted machines to automate calculations. This led to the development of mechanical calculators. These early machines used gears and levers. They could perform basic arithmetic operations. These early inventions laid the foundation for the modern computer age, and they demonstrated the human desire to calculate and compute. Charles Babbage, a British mathematician, envisioned a different kind of calculating machine. He lived in the 19th century. Babbage conceived of the difference engine. It was a mechanical computer that could calculate and print mathematical tables. The difference engine was a groundbreaking idea. It was designed to automate the tedious work of human computers. Babbage's ideas went even further. He proposed a more general-purpose machine called the analytical engine. The analytical engine was designed to perform any type of mathematical operation. It had many features we associate with modern computers. These features include memory, a central processing unit, and punched cards for input. Ada Lovelace, a brilliant mathematician, collaborated with Babbage. She is considered the first computer programmer. Lovelace wrote algorithms for the analytical engine. These algorithms were designed to solve specific mathematical problems. Her work laid the foundation for the development of software. The 20th century saw a paradigm shift in computing with the advent of electronics. Vacuum tubes became the building blocks of early electronic computers. These tubes controlled the flow of electricity. They enabled the creation of faster and more complex calculating machines. World War II accelerated the development of electronic computers. The need to break enemy codes and perform complex calculations led to the creation of machines like the Colossus and ENIAC. The Colossus, built by the British, helped decrypt German messages. The ENIAC, built in the United States, was one of the first general-purpose electronic computers. The transition from vacuum tubes to transistors was a pivotal moment in computing history. Transistors were smaller, faster, and more reliable than vacuum tubes. They consumed less power and generated less heat. The invention of the transistor revolutionized electronics. It paved the way for the miniaturization of computers. The invention of the integrated circuit, or microchip, was a watershed moment in the history of computing. Jack Kilby and Robert Noyce independently developed the integrated circuit. It allowed for the placement of thousands of transistors on a single chip. This miniaturization led to the creation of smaller, more powerful, and more affordable computers. The development of the microprocessor in the 1970s further revolutionized computing. A microprocessor is a central processing unit on a single chip. It paved the way for the personal computer revolution. Companies like Apple, Microsoft, and IBM played pivotal roles in bringing personal computers to the masses. The Apple II, the IBM PC, and the Macintosh were iconic machines that popularized personal computing. Section 5, the software revolution. From algorithms to user interfaces. The development of hardware went hand in hand with the evolution of software. Operating systems like Unix and MS-DOS provided a platform for software development. Programming languages like C and C++ emerged. They provided powerful tools for creating complex applications. The graphical user interface, or GUI, revolutionized the way people interacted with computers. Instead of typing commands, users could interact with visual icons and menus. This made computers more accessible to a wider audience. Companies like Apple and Microsoft played a crucial role in popularizing GUIs. They continue to shape how we interact with computers today. Section 6, the networked world connecting minds and machines. The The development of computer networks transformed computing from a solitary activity to a collaborative one. The ARPANET, funded by the US Department of Defense, laid the foundation for the Internet. The Internet connected computers around the world. It enabled the sharing of information and resources on an unprecedented scale. The World Wide Web, invented by Tim Berners-Lee, made the Internet accessible to the public. The web provided a user-friendly interface for accessing information, sharing content, and connecting with others. Search engines like Google emerged. They helped users navigate the vast expanse of the Internet. Social media platforms like Facebook and Twitter connected billions of people worldwide. Section 7, the Age of Artificial Intelligence, from Algorithms to Autonomy. Artificial intelligence, or AI, has become one of the most transformative technologies of the 21st century. AI encompasses a wide range of techniques. These include machine learning, deep learning, and natural language processing. AI systems can analyze vast amounts of data. They can identify patterns, make predictions, and even learn from their mistakes. AI is being used in a wide range of applications. These include self-driving cars, medical diagnosis, financial trading, and personalized recommendations. AI is also transforming the way we interact with technology. Virtual assistants like Siri and Alexa use AI to understand and respond to our commands. AI is poised to revolutionize many industries and aspects of our lives. Section 8, Quantum Leaps, exploring the frontiers of computation. Quantum computing represents the next frontier in computing technology. It harnesses the principles of quantum mechanics. Quantum mechanics is a branch of physics that studies the behavior of matter at the atomic and subatomic level. Quantum computers use qubits instead of bits. Qubits can exist in multiple states simultaneously. This allows them to perform computations exponentially faster than traditional computers. Quantum computing has the potential to revolutionize fields like medicine, materials science, and artificial intelligence. It could lead to the development of new drugs, more efficient solar panels, and more powerful AI systems. However, quantum computing is still in its early stages. Significant challenges remain in building practical and scalable quantum computers. Section 9. The enduring impact, shaping the future, one bit at a time. The journey of computers from simple calculating devices to sophisticated AI systems is a testament to human ingenuity. Computers have transformed our world in countless ways. They have revolutionized communication, entertainment, education, healthcare, and many other industries. The Internet and social media have connected billions of people worldwide. They have created new opportunities for collaboration, innovation, and social change. As we look to the future, computers will continue to shape our world in profound ways. Artificial intelligence, quantum computing, and other emerging technologies hold immense potential to solve some of humanity's greatest challenges. However, these technologies also raise important ethical and societal questions. As we continue to develop and deploy these powerful tools, we must do so responsibly and thoughtfully, ensuring that they benefit all of humanity.